Hello again, and welcome to episode 3 of Penrose From Scratch. Last time around, we had a look at adding a couple of quality of life things so that the minimal example that comes out of the sort of Penrose examples directory is usable. Minimal really does mean minimal. We added a status bar. We added support for EWMH, which stands for Extended Window Manager hints, which is stuff like programs requesting themselves to go full screen or reposition themselves, stuff like that. And we had a very brief look at layouts. We'll have a proper look at layouts. We'll take at least an episode, maybe 2, having a look at all the things that are available there. It goes from really, really simple to super fancy and lots of freedom for you to lay out your windows exactly how you want. So we'll want to go through it slowly, I think. And then the last thing we had a look at was adding a couple of key bindings so we could actually get out of Penrose. So if you remember, we're actually running inside of a shell script. So rather than just running the Penrose binary that we're going to make, or Penrose from scratch binary, I should say, rather than just running that, we are wrapping it in this script so that when we exit our binary, because we've edited stuff and recompiled, for example, then we actually loop around and restart. And that lets us kind of edit the window manager while we're inside the window manager, which is nice. It's a much nicer experience than having to log out and log back in every time. Because of that, there's a couple of quirks with key bindings where the exit helper that I provide for you, which should exit Penrose for you, does exit Penrose, but doesn't exit that shell script. So exit actually isn't exit for us, it's restart. And to actually fully exit, we need to kill that shell script as well. So that's what this pkill fi is. And that's where we kill the binary and the wrapper shell script, and that actually exits out to your display manager or your login screen, whatever you want to call it. So main thing we're going to do today is we're going to have a look at how key bindings work, what's kind of going on under the hood, so that you've got a bit of an idea about how to write your own actions for things. And then we'll tidy this up so that instead of it being 2 key bindings that are pretty much the same, and yes, I know I've done that deliberately. I know that's kind of a straw man argument, but meh. To save our fat fingers from accidentally closing the window manager instead of restarting, we're going to use dmenu to pop open a little kind of selection window and pick what we want to do. If you've not seen before or forgotten what dmenu is, it's this. It's a super simple little UI element that lets you select from lines of text and pick one of them, pretty much. But that then gets returned to whoever as the output of dmenu. So when you call it as a program, you provide options in, you get an option back out, and it lets you kind of do simple UI stuff without actually having to write full UI code, which is always nice. So we're going to use that for making our little kind of logout power menu kind of thing. But before we do that, we need to have a bit of a chat about how key bindings work in Rust. So the kind of plan of attack for today is this. So review the logout and restart key bindings we wrote last time. We've kind of done that. Success. And we're going to have a look at the KeyEventHandler trait. Now, I mentioned this last time. Traits in Rust are how you do kind of generic shared behavior. So they're kind of like interfaces, if you've worked in kind of OO languages before. They're not exactly the same thing as interfaces, but they're super, super helpful and super handy. Now, I'm not going to go into a big deep dive of how traits work and all the kinds of things you can do with them and all the gotchas and cool tricks and bits and pieces. There is a fantastic section in the Rust book on traits. There's also I think it's called Rust by Example, is really good. It's got some good stuff on traits. And there's some fantastic videos on YouTube on Rust traits and how they work and all sorts of bits and pieces. If you want to find out more, that's a good place to start. But yeah, the key event handler stuff, that's a trait. We'll have a look at what that trait is. It's possibly one of the simplest traits you could write. It's got one method, super simple. But I'll explain why we need a trait rather than just what you might expect. There's something that we'll have a look at, which is a little helper function that's called KeyEventHandler. That helps you kind of generate instances of this trait. It just sort of takes a bit of the boilerplate away, makes it a little bit nicer to work with. And there's some extra kind of helpers are built up on top of that let you do kind of common things. We're actually making a use of a bunch of them already, so we'll have a look at that in a sec. But yeah, all these things are building up something that's called a trait object. And that's kind of Rust's answer to doing kind of dynamic typing. And kind of the old kind of duck typing thing from Python of like if it walks like a duck and quacks like a duck, it's probably a duck. We've got type check ducks, but you get the idea. Yeah, after that, we'll have a look at modify and refresh. That's kind of what all this stuff kind of feeds into. Like whenever you're interacting and running your own logic within Penrose, you need to prompt the window manager to actually refresh everything that's on the screen. And so I think I mentioned this last time, Penrose has got a kind of diff and render model where it keeps track of the kind of what the logical state of everything is. And anytime that you run your own custom code to modify that, it computes a diff with the last thing it knew, and then that diff lets it work out what it needs to render. And yeah, by the time we've gone through all that, we'll be ready to crack out dmenu and write our own key binding handler. That'll be cool. So let's start with why we need a trait in the first place and what boxedin is about. So when we're building our raw key bindings, you'll see that what we're returning is a hash map of string to boxedin KeyEventHandler RustConn, which is a super snappy, easy to read type signature. Yeah, and that boxedin bit is the kind of dynamic typing stuff I'm talking about. Box is, what is the docs? Save the box, actually. Yeah, pretty much what I thought. A pointer type that uniquely owns a heap allocation of type T. So T there is generic, and basically means you can kind of put anything you want in a box, and it will allocate that memory on the heap rather than in the stack, and give you back a pointer to where that memory is. And so that lets you kind of allocate memory and keep track of it and pass that pointer around so you can do things with it. But the din key event handler bit is just a layer of indirection that allows us to have kind of one type that the Rust compiler can work with. And that gives us our kind of nice dynamic typing. Because instead of saying this is this specific key handler, this is a pointer to a thing that is a key handler. And a pointer is always the same size in memory. And so, and you can always treat it the same way because we know we're pointing to a thing that is a key event handler, so we can do key event handler things with it, but we can't do anything else. So any kind of type specific stuff for the particular key event handler that we're working with, we don't have access to that when we've got a boxed in key event handler. We can do key handler stuff, and key handler stuff is call the key handler. That's it. It's pretty simple. This is why you can use simple, like just a function with the right signature as a key event handler. But if you want to do something fancier, if you want to kind of track state or configure things in a sort of a more interesting way, then you can implement this trait yourself for whatever type that you want to work with and register that as your key event handler. But those helpers that I was talking about, the kind of key, what was it? I keep forgetting what it's called. I wrote the damn thing. Key handler, that's what I called it. Key handler, modify with, send layout message. These are all things that will build a key event handler for you out of a function that you give in. And then you've got some things that just are key event handlers, like spawn, which will spawn that program, just as if you've typed it in the prompt in your terminal. and exit will exit the window manager, for example. So those are kind of canned ones that do one specific thing. Send layout message is a way of interacting with your layouts and prompting them to do stuff. So you can kind of tweak the layouts as they're running. So the simplest one to kind of demonstrate is that one there, which is kind of shrink and expand main. So that kind of, this section on the left is referred to as the main section, and you can make it bigger or smaller. It's kind of fun. But that's being handled by sending a message to that layout, which the layout understands how to react to, and goes, oh, cool, I need to change how I'm laying out the windows. This is part of why we're going to have a whole episode on layouts, is you can send messages to layouts. You can write your own message types. They too are a dynamic thing that you can kind of set up and configure how you want. You can nest layouts inside of layouts. You can do loads of stuff. So we'll leave it at that for now, and we'll come back to layouts later. Modify width is probably the one you're going to see the most. And this is that diff the pure state and re-render kind of thing. So CS here stands for client set. That's the kind of data structure that is everything that you see on screen. So at the top level, you've got screens. Screens hold on to workspaces. Workspaces can be moved around between screens. So you can say, I want to have workspace 2 at the moment, or maybe I want workspace 3. Or maybe I want workspace 7, which has got nothing on it at the moment, but I could spawn a terminal on workspace 7. I could close a terminal on workspace 7. I can go back to workspace 2. So all of that is modifying that client set. It's changing which workspace is active on the screen. So workspace 2, workspace 3, workspace 4. It's changing how many clients are there. So if we open a new program, we've added that client into workspace 2, and I can change the ordering of those clients. I can change which client has focus. I can get rid of one of the clients. All of that stuff is things which we handle at the kind of logical layer and then reflect those changes out to the X server. The reason for doing that is well, two things. One, code that you write doesn't need to care at all about the X server. This is a good thing. X programming is insane. You want to avoid X programming. It's a mess. So that's a win. That's good. The other thing is, for me, writing all this stuff, it makes it way easier to test, because I can test all of that nice pure logic where I just say, cool, I'm going to manipulate that data structure and call a bunch of methods, send a bunch of events, do various things, and this is the kind of state I should end up with at the end, or this is the diff I should get at the other side of that. And I can kind of check that that stuff all kind of propagates correctly without having to interact with an X server. And then for the X server stuff, all that needs to be able to do is, for a given diff, it produces the correct output. And so, yeah, breaking it apart like that makes it nice and easy to manage. But yeah, modify with is a way of saying, you give me a function that will modify that pure state. We'll modify the pure state. We'll check what changed, and then we will re-render based on that diff. Now, modify with is, well, it's calling this modify and refresh function. That's kind of the core of Penrose. That's what's doing this kind of stuff that I was talking about, where we call your function that updates the state, and then we make a diff, and then we stash that away in the state, and then based on that diff, a bunch of stuff happens. We map and unmap windows, we reposition things, we set properties on windows, we set what has focus so that when you're typing, the key input goes to the right place, all that kind of stuff. But again, we'll come back to that later. There's a bunch of stuff we can dig into with the kind of main Penrose event loop and all that kind of stuff further down the line. At the moment, we just want to get the window manager working the way we want it. And if we look a little bit above, you'll see there's this key handler helper, which is the one that we're going to use in a sec, which is even more simple. That one is just go and do something. This one doesn't necessarily immediately trigger a refresh. This is just, cool, I've got access to state, I'm going to go do something. The modify and refresh one is do something and then refresh what's on screen. So what we're going to do is something which is isn't really going to need to refresh what's on screen because we're not going to do anything with the kind of screens and workspaces and clients. We're going to pop up this dmenu window, which is kind of a little transient thing that the window manager will just kind of let float in the middle of the screen. And then we're going to process some input from it and take some actions. So let's have a look at that. So for that, we're going to need a function that makes our handler. So we're going to call this power menu. And this is going to return altogether now a box din KeyEventHandler RustCon. Is that the right number of curlies? Yes. There we go. Cool. So that's what we're going to make. Now, what we need to return from that is our KeyEventHandler. So we need that helper. So if we go back to the docs, you'll see that the key handler lives in built-in actions. And we just use that to wrap a function that has the right signature. So if we go to built-in actions in here, we can import key handler. And then in our power menu function, we can call key handler. And this needs to take two parameters. So it takes a state, which is a mutable reference to a state RustCon, and it takes an X, which is a reference to a RustCon. And this needs to return a result. And so that is kind of the, oh, I don't have state in there. Actually, I don't, this is a closure, so I don't need those types. And then it's just a little bit easier to read. So that takes a state and an X. And yeah, that's unused, but that is a valid key handler, which is when we trigger that, don't do anything. So that's kind of possibly the simplest and least useful key handler we can write, but it's syntactically valid, it type checks, and everything we can do from here is a step up. So let's actually make that a bit more useful. So the first thing we're going to do is we need to work out what screen we're on. So if we get the state and we pop off the client set, then we can call some methods on that. This is not, nope, this is let index. Is this going to type check or autocomplete for me? There we go, it is cool, it worked out what we're working with now. So we want current screen. I think that's what I want. Let me double check. I've got something that pretty much works with this. Yeah, and I want the index off of the current screen. Index, cool. So that will give us a usize. So that is basically telling us which screen index we should render the dmenu menu on. And then if we have a look at the docs for the dmenu helper, we're going to use a method that's called build menu. Now that is going to be a thing that lets us basically pop up something a bit like this. So we're going to tell it the choices that it should have in the menu, and then we're going to run it, and it's going to give us back whatever the user selected. And then it's our job to then do something with what came back. Now, this is how we're going to set this up. Oh, screen index. Okay, let's call it screen index. That's a bit clearer, I suppose. But for this to work, we actually need to have dmenu and dmenu config. So those are brought in from Penrose extensions util dmenu. So Penrose extensions util dmenu, and we're going to have dmenu config, and also we're going to bring in this thing called menu match. So menu match is what we get back out of dmenu, essentially. Now, there's a couple of different things that dmenu can do when it runs. So if we come in here and I type in, what should we type in? Chromium, for example. Chromium is an option. I can also type in like Bob. Bob and a space. There we go. So I can type in Bob and a space. That doesn't match any of the options that we were told to pick from. And so what dmenu will return there is literally that string. I'll say, cool, that wasn't an option that you were supposed to pick from, but the user inputted Bob space. So do something with that. What we're going to do with that is completely ignore it, because it's not a valid option. The other thing you can do is escape out of it, in which case you're going to get nothing. So all of those are kind of covered in this menu match. And we're going to have a look at just if you selected a valid option from what we'd fed in. Because anything else we kind of don't really want to deal with. So we need some choices to work with. And so our choices are going to be restart Penrose and logout. Those are going to be our two things that we're doing. Because if you remember, we said we were going to take the... Oh, where are we? Oh, that's not where I want it to be. This is where I want to be. We're going to take these two helpers here. And that's what we're going to put into our dmenu. Now, if we go back to the docs on dmenu and we look at build menu, this is what we need to do. So we need to do dmenu, build menu, choices. Now that's going to return a result because we're spawning an external program, we're asking real life system things to happen, anything could go wrong. So that unwrap in the example, in general you don't want to use that in your window manager, because if you're in the error path, that's going to panic your window manager and everything's going to die. So don't do that, that's a bad idea. What we're going to do is only handle happy path stuff. So if there's an error, we're going to ignore it, but we're not going to unwrap it. We're just going to say, cool, something went wrong, we can't run the menu for you. Now this is matching all the different options that we've got. So whether it was that selected line, whether it was something the user inputted that we don't really know what to do with, or whether it was no match, so whether they kind of just exited out of dmenu without doing anything. We only care about this option where they selected one of the inputs that we actually gave them. So that dmenu build menu choices is what we're going to work with, and we're going to use something called if let. So instead of matching on every option, we're just going to say if one of them matches. So if let okay let. So this is going to be menu match line, and we don't care about the index, but we do care about the choice. So if it matched, we're going to do something. If it didn't match that, so if it wasn't a menu match line, so if it wasn't a selected line, or if there was an error, we don't care. We're not going to do anything. There's nothing sensible we can do at this point for our little menu that we're writing. But if we did get something, then we are going to match choice as ref, which means that we can match it as a string literal. So we're going to then match those two strings. Restart Penrose. So if it was restart Penrose, we need to restart. And if it was logout, we need to kill Penrose and the wrapper. Cool. Oh, why is that not working? Oh yes, sorry, I've not covered everything, have I? So if we're saying match a string, there's actually loads of stuff that could come back. But the other thing we're going to do is say, well, if it's anything else, we don't care. Cool, okay, so now we have our power menu. And that means that down here, we can change mod alt escape to be our power menu. We don't need those comments anymore because everything's kind of in the power menu. And our power menu is in use. Oh yeah, we're not actually using the X connection. We don't care about querying or modifying the X state, so we can just replace that with an underscore. That's fine. But those to-dos are things we need to actually do. So if you have a look up here, there was an exit thing that we had, but that was exiting as a key handler. We want to actually exit. So to actually exit, we're going to take something in from the standard library, which is just process exit. And this is just the standard thing where you exit with an exit code. So restarting is just going to be exit 0. And that's fine. And then logging out, we need to spawn a program. Now we have spawn down here, but this, again, this is a helper that makes a key event handler. We want to actually spawn the program, not have a key handler that when we run it spawns the program. Hopefully that makes sense. So what we're going to do is there is a util directory, or a util module rather, and that's where the thing that's being wrapped by that key handler comes from. So if we go to util spawn, that will actually spawn the program straight away rather than make a key handler for spawning the program when the binding runs. So this is where we get our pkill-fi Penrose. Penrose. Cool. So we've got that. Did I mess anything up? No, that looks okay. No errors. Cool. So let's recap. So we had 2 different key bindings. We've now replaced mod alt escape with running our power menu. Our power menu is a key handler. That's going to generate our boxed in key event handler rustcon. That's our trait object that is yo dog pointer to the heap. This thing can handle keys. And for our key handler, we only really care about state. That's it. And the only reason we even care about state is we just want to know what screen is currently focused so that we pop this thing up on the right screen. We're going to make our helper that wraps around dmenu. Dmenu config here lets you kind of set up a bunch of different things. Oh, should we do that? Maybe we could do that. I think this is where, is this where we, I forget now. Is this where we set the prompt? Custom prompt. Yeah, let's do that. Let's have a prompt. Why not? Let's do that. Ooh, dear. That's not what I meant to do. There we go. That's what I meant to do. And let's say custom prompt, and that's going to be some string. So our string is going to be that. Ooh, I cannot type. Cool. So that just means that we can set. So here, there is no prompt. Like if you have a look there, there's just nothing there. This means that we can have a little triple arrows. Why not? We can think of something fancier to do later. But yeah, that sets up our dmenu. And then we have our choices, which is restart Penrose or logout. And then we're going to run that menu and see what the user gave us and then do something accordingly. If they pick something that doesn't make sense, then we just ignore it. Cool. So we've got that. We're going to run our usual make build and sudo make install. And then we're going to restart Penrose twice. So first time around, we're compiling new code. This should exit out of Penrose and get picked up by the wrapper script, but it's just going to exit straight away. That's the key binding that we had. Second time around, we'll be running the new code, and when we hit mod alt escape, it should pop open a little menu for us. So fingers crossed, that will work. And we'll see how we go while we wait for Rust to compile. Because Rust is slow at compiling. There we go. Cool. I vamped for long enough. Right, so mod alt escape. This should just restart without the menu. Cool. There we go. That restarted just fine. And then this time around, if I do mod alt escape, we get our little menu with our prompt. We get our little triple arrows. Fantastic. So we can do restart Penrose, or we can do logout. So if we do restart Penrose and hit enter, that should restart it again. And we restart again. Hey, isn't it wonderful when code works first time around? I say first time round. I've actually tried recording this video multiple times, and things have gone wrong every single time. Well, no, not wrong with the code, but wrong with the recording. So yeah, the code's fine. Code works well. So let's have a look. So we looked at the trait. That was fine. We looked at the key handler helper function. We had a quick look at modify and refresh, and we've rewritten our key bindings to use dmenu. Cool. So next time round, what should we have a look at? Well, we can look at layouts, or we can look at hooks. I'll have a think about which one's more important to look at first. Layouts is kind of a big topic. I think maybe we'll look at hooks, because then that means we can get like a startup script running, and it also means that we can get something setting this part of our status bar up at the top. Not that you'll be able to see it in the videos when my face is up here, but maybe we can move the status bar down to the bottom so you can see it. Let's do that next time as well. Okay, so next time, hooks. We'll get hooks all set up, and then we can do a proper deep dive into layouts, because there's a whole bunch of stuff to do with layouts and some fun things to kind of play around with. But until then, I'll push the details up to the Git repository. Everything we've just done will be up there if you want to crib for anything. If you've got any questions, feel free to ask in the comments, but if you've got feature requests, bug reports, anything like that, please pop them in the issue tracker in GitHub, and we'll be able to have a look there. And I'll see you next time. Happy Window Manager hacking, everyone.